Alright guys, so today's video is going to be about the properties of logs and kind of how using these properties that we are given about log functions, how we can use them in order to solve equations, solve for answers, solve for functions, so on and so forth. These properties are what allow us to be able to manipulate these functions, or what allow us to be able to figure out what the answer should be. It's a very, very, very good idea to have a good understanding of what these properties are, how they work, and essentially knowing those properties in order to solve your problems is key. And so knowing these properties, I highly encourage you to memorize them, or at least be able to know an idea of what they're going to be. The first property here is if we have the log of base 10, so all these here are the same base, and that's something else that you want to keep in mind. The only ones that have a different base is this guy right here, which is log base b. I'll get to that when we get there though. So all these guys here have log base 10, and so if we have log of a times b, it's the equivalent of log of a plus log of b. For this one here, we have log of a divided by b is going to be the same as log of a minus log of b, or log of a subtract log of b. And then for this one here, so as I was saying, this is the only one that has a base change in it. And when you think of base change, this is what you're thinking of. Where log of base b of a is the equivalent of log base 10 of a over log base 10 of b. Now, the proof and everything to that, I will leave in another video just as to why that is, as well as the proof of every one of these here. However, for now, accept it at face value, and I will definitely be able to dive into that for another time. So we have log base b of a is equivalent to log of a, our numerator, divided by our denominator. And another way to think of this is if we have base as in bottom, it's always going to be in the denominator, in the lower position of our fraction. All right, and then we finally have log base a to the b power. So log of a to the b power. Well, our exponent in this case, or what the exponent of a is a to the b power, or bth power. From there, we have our b is allowed to be able to move out front, and it turns into b times log of a. And so these four properties right here is what gives us our rules to be able to work with log functions. These are the ways that we can go about solving log functions. So without further delay, let's see if we can do a problem real fast and get into it. So we have log base 7 of 4 times c times d. There's markers going out just a hair. So if we take a look here, we have 4 times c times d. Okay, well, taking a look at our first property, if we have log of a times b times, well, c that's just going to be the equivalent of log of a plus log of b. Okay, so we have log base 7 of 4, which is our first one right there, plus log of 7, our second coefficient, which is going to be c, plus log of 7 times our last coefficient, which is going to be d. And so that's the expanded form of our log equation here. We have 4 right here, 4. We have d, and d. And then finally we have c and c. And so, if we take a look at it from our property up here, we have log of A times B is the equivalent of log of A times B. Well, log of A plus log of B is the equivalent of those things, and this D is just tagged along there for the ride. All right, our next problem here, let's take a look. We have log of, so log base 3 of 9p squared over q to the 5th. I'll go ahead and make sure that I continue making this little curly tail on our q so that way you can tell the difference between q and 9. Okay, so taking a look at this, if we take a look at our second log property here, well, if we know that log of a divided by b is going to be the equivalent as log of a minus log of b, okay, so we have our numerator up top, just this guy, divided by our denominator, this guy right here. Well, we can rewrite that using our properties. So we have log of 3 of 9 times p squared minus, let's get that minus from right here, minus log of 3 of our denominator, q to the 5th. Okay, we can do this one step further. And that next step is going to look at 9 times p squared. Okay, well, we have one coefficient times another coefficient. These can just be separated even more, or separated again. And now we have log base 3 of 9. Separated out, we have plus log base 3 of p squared. That's bad too, sorry about that. Log base 3 of p squared minus log base 3 of q to the 5th. All right, we are almost done, we're almost done. Last thing that we have is we have exponents, and we need to get rid of these exponents. We need to expand them out one step further. With these exponents and with the properties of logarithms, we can bring these exponents out front. So now we have log base 3 of 9 plus 2. So we bring in that exponent out front, plus 2 of log base 3 of p minus, bring out that 5, and we have 5 here. There we go. Minus 5 times log base 3 of q. And voila, we are done. This guy right here, we can actually simplify this one more time. I'll leave that to you guys, to what we can simplify log base 3 of 9 to. But this is our answer right here. Let's do one more. Let's see if we can get one more in. And so again, that's kind of how we use these properties in order to solve our functions. By knowing the properties, we can get the answer that we're looking for, and by knowing these properties, we can use them in order to get to a simpler expression. Okay, let's take a look. So we have log base 10 of x plus y to the 4th over 7. Okay. Okay, well, taking a look at this, we have log of x plus y to the 4th over 7. Where can we start? Well, we can either start with this guy right here, using our second property where log base a minus, log of a minus log of b is equal to log of a over b, or we can use our other property here of log base b of a is equivalent to log of a divided by log of b. You know what? I think what I want to do is, looking at this, we only have log out front. If we were to have log of x plus y to the fourth over, if let's say we were to have log of 7, then we would be able to use this guy right here. But because we only have a single log out front, that means we have to use our law of division, or logs of division. So what this means is we have to do log of x plus y to the fourth minus log of 7. And so the way that we got that is by looking at our properties again. We have the top minus the bottom, top, which is A, minus the bottom, which is B. And so in this case, we have our numerator and our denominator. Again, the base here is just going to be base 10, which is the implied base. And then looking at this guy right here, we have log of x plus y to the fourth. Well, x plus y to the fourth, we can actually rewrite this as 4 times log of x plus y minus log of 7. Okay, so now we have log of x plus y. Can this be divided, or can this be simplified anymore? Well, taking a look, we have log of a times b, log of a divided by b. But unfortunately, we do not have anything that gives us log of a plus b. So this guy right here, this single coefficient, which it will come out to be, this is our simplified version. So bringing out our exponent to the front of 4, we get 4 log of x plus y minus log of 7. All right, last problem here. So we have the natural log of the cube root of xy squared over t cubed. Okay, taking a look at this again, we have a numerator and our denominator right here. Let's go ahead and rewrite this guy out. So we have our numerator, or the natural log of the numerator, minus the natural log of our denominator. So we have natural log of our numerator, which is going to be the cube root of xy squared, minus the natural log of our denominator, which is going to be t cubed. From here, we can go ahead, we can rewrite this natural log here as natural log of xy squared. This here was supposed to be the cube root. Forgot that right there. Sorry about that. Cube root, which means this is a third. And this is going to be raised to the 1/3 power, minus our natural log of t. Well, taking a look at this guy, we can actually simplify this a little bit farther right now. So natural log of t to the 3rd power. Well, this 3 here, we can actually go ahead and just bring that out front. And now we have 3 natural log of t. Now we need to simplify this expression a little bit further. Taking this, we'll have the natural log. And just copy it real fast so that way there's some more room to work with. To the 1/3 power. Okay. Yep, all right, we're good. So, taking a look at this, our 1/3 can actually be brought out front. We have that coefficient again that can be brought out to the front. So, now we have 1/3 natural log of x, y squared. And for this guy right here, to make sure that we know it's going to be contained, we go ahead, we put some parentheses around it so that way it stays all in order. All right, finally, let's take a look at this guy. We have the natural log of x times y squared. Well, we know that. Okay. So we have natural log of x plus the natural log of y squared. Don't forget, this is all to the 1/3. Finally, last step right here, we have 1/3 open parentheses to the natural log x plus, well, we have an exponent here, so our y is being raised to the second power. Our exponent can be brought out front again. So we have plus 2 natural log of y. And finally, close parentheses. And so that's what this term in our equation is going to be equivalent to. So finally, let's write this out in something nice and see if we can make it look a little bit better. So we have 1/3. Let me go ahead and erase some of this stuff real fast. There we go. So we have 1/3 times the natural log of x plus 2 times the natural log of y, close parentheses. So that takes care of this term, or this term. All we have left is minus 3 natural log of t. And that's it. This is our answer. Alright guys, that's going to be it for this video. I'm going to make another video to where we essentially go the opposite way.